Hello, hello, hello. Practice test. Lots of questions. A total of 41, so it's probably going to be pretty long. And a bummer, I forgot my writing utensil at school. And on this cold winter night, I'm not going to drive to go get it. So you're going to have to deal with the fact that I'm going to be using my fat finger to be drawing. First one. You can use your calculator, so if you're not sure, you should always be able to check to see if you can take the square root of 256. If not, then you can do your factor tree. And to the square root, we're looking for pairs of 2. So here's a pair of 2, here's a pair of 2, here's a pair of 2, and here's a pair of 2. Nothing else is able to be circled, nothing else would be boxed in. So we multiply 2 times 2 times 2 times 2. And if you did that, you would get 16. So my first answer would be 16. Again, you could use your calculator to get that answer. First answer, 16. Same type of thing for the second one. 64 is a cubic group, but if you're not sure, you can do your factor tree. And now I'm looking for groups of 3 because it's the cubic root. So if I'm looking for groups of 3, here's a group of 3, here's a group of 3. So this first answer on top would be 2 times 2, which is 4. If you notice on the bottom, I already see a group of 3/8, so I didn't go any farther. So this would be 4 over 8. And since I'm beginning my answer with a negative, the cubic root means I'm still going to have my answer as a negative number. So here's what I have, and then you should still be able to reduce. Now one thing you might be thinking is, can I reduce first before I actually do the cubes? Yes, you sure can. If that's what you feel like doing, you can reduce your 64 over 512 and then take the cubic root. And this third one, you should know cubic root of 8 right away. The cubic root of 8 is 2. And because this would be negative times the cubic root of 8, this would be a negative 2. Fourth root of 1,296. Again, check to see if it has a fourth root. Otherwise, your factor tree. So now I'm looking for groups of 4. Here's a group of 4. Here's a group of 4. So it'd be 3 times 2, and 3 times 2 is 6. I wonder if you can hear my kids now in the background. 6 right there. Answer 6. Next group, if you look at this, it says use absolute values if necessary. So now I'm taking the square root of 121. You should know the square root of 121 is 11. And the square root of g to the 10th. Remember, you're looking for groups of 2. So if you divide 10 by 2, you can get 5 groups. Now I'm going to write g to the 5th. Now I have to decide if I need absolute values. So I have to look, can I take a square root of a negative? No, because this is an even root. Could this end up being negative? Yes, because this is an odd power. So if this is an odd power, but an even root, I have to have absolute values. Remember, when you're doing these absolute values, it should be just around the variable that needs them. So in this case, just the g. It should not include the 11. Question number 6, if you look, we already found the fourth root of 1,296, and that was 6. And then I'm looking at x to the 8th. How many groups of 4 can I have? I can have 2 groups of 4, so that leaves me with x squared. And how many groups of 4 can I have with y to the 4th? That'd be y to the 1st. So again, you're thinking, can I take the fourth root of a negative? No. Can I get a negative here? No, because this is squared. Could I get a negative here? Yes. If y was negative, that would be negative. So I'm just including the y in my absolute value. That's the only one I'm including. Next one, cubic root. Cubic root of 64 is 4. And then how many groups of 3 do I have with 6 x's? I have 2 groups of 3. So that'd be leaving me with x squared. Can I have a negative? Can I take a cubic root of a negative? Yes. So I don't need any absolute value. Square roots. Square root of 9 is 3. Square root of 36 is 6. And actually, I can already reduce that, so I'm going to make that into 1/2. And then the square root of x to the 6 would be x cubed. Can I take the square root of a negative? No. Could I get a negative here? Yes. So this needs to have absolute values. You do not have to include this one there, but you sure can if you want to. Look at this. Look at this. For the remainder of the test, assume all variables are positive. What does that mean? We do not have to do anything with our absolute values for any of the rest of the test. Nothing. So first one, I can multiply my two roots because the fact that they're both square roots, they have the same index. So if I do 30 times 6, I'm going to get the square root of 180. So if I have the square root of 180, I'm going to do my factor tree here. And with the square root, I'm looking for pairs. Square root, remember there's always like a little 2 here. The index there is 2, so I'm looking for pairs. So I have a pair of 3s, I have a pair of 2s. I have this 5 that doesn't have a pair of 3s or a pair of 2s. So I multiply. Anything that circles get multiplied. So 3 times 2 would give me 6. And then I have that 5 left over. That stays within the root. So my answer would be 6 square root of 5. Same type of thing here. Both of these are cubic roots, so I can multiply them together. And I have 27, and the cubic root of 27, that's another one that you should just kind of know. So the cubic root of 27 would just give me tree. Now one thing, whoopsie, daisy, 3, right over there. Question number 11, again, I multiply them together. And when I multiply them, I get a negative number. And I notice I have a group of 7s right here. Now, one thing here, some people might be able to say, okay, I know this for sure is 7 times 7, so here's my group of 3. Some people do not have to multiply that, and that's okay. Either way, you should see they have a group of 7s. And the fact that since it's a positive times a negative, that makes it a negative number, so then your answer will give you a negative number. So your answer would be negative 7. And the last one, 2 times square root of 8 would be the square root of 16, and you should know the square root of 16 is 4. That's one of those you just got to know. Next section, so I'm simplifying here. So I'm looking for groups of 3 again. I'm looking for groups of 3, so first thing when I'm looking at this number, I'm going to have to use my factor tree. So here's my factor tree. I'd look at my index. That's what I should be looking for groups of. So I'm looking for groups of 3. So here's a group of 3. And right here's a group of 3. And this one's left over, so I'm not doing anything with that. The other thing you might notice is that I already rewrote my A's. So I wrote A to the 15th because I know I can get a group of 3 for evenly out of there. And a group of 12 is already can be divisible by 3, so I can find groups of 3. So what I have is the 2 times 3, which would give me my 6. And the A to the 15th can be reduced to A to the 5th. B to the 12th, the cubic root of B to the 12th would give me B to the 4th. And then I have the cubic root of 5. Now in a problem like this, this little guy would give you points off if you don't remember it. So my final answer is 6, A to the 5th, B to the 4th, cubic root 5A, because remember this A was left in there. I didn't put it here. Sorry, but it is over here. You should put your final answer on the line. Next one, the first thing I'm going to do is multiply them and do my factor tree. Actually, I lied. I'm not going to do my factor tree. And one thing you might notice is, why aren't you going to do the factor tree? Well, do the factor tree if you must do it. However, this is the square root of x to the 4th. That's what I have written right here, square root of x to the 4th once you multiply those together. You should know that the square root of 16 is 4. And the square root of x to the 4th, I have 2 groups of 2 there, so that would give me x squared. And the last one, so first thing I'm going to do is multiply my 2 cubic roots together. Here you cannot forget your properties of exponents, so you're multiplying the 2 y's together. This is y to the 1st. 1 plus 2 will give you the 3, and 9 times 24. So now I'm going to do my factor tree, or else I could check to see if it's a perfect cube. But if you do the factor tree way, here's a group of 3. Again, I'm looking at my index here is 3. That's why I'm looking for groups of 3. Here's a group of 3. So I can multiply those together. One thing I cannot forget, 3 times 2 is 6. But I also have to multiply by this 5. This 5 from the get-go. So I have my 5 times 2, which is 10, times 3, which is 30. And then the cubic root of y cubed would give me just y. Why? Because I like you. If you know what I'm talking about, it's the Mickey Mouse Clubhouse. Next one, divide or rationalize the denominator. No matter what, I don't want to have any answers with any roots in the bottom. First thing that I'm going to do here, though, is see if I can simplify my fraction. And I can. 270 is divisible by 5. So if you do 270 divided by 5, you would get the cubic root of 54. And this is where you can do your factor tree. And that factor tree would show me that I have a group of 3 right here. So I have one group of 3 of 3s, and then I have a 2 left over, which I would box in. So my answer would be 3 and then the cubic root of 2. Now again, if I leave my answer like that, you're not going to get full credit, which would be sad because you have it all. You just need to have that little 3 because you need to have that index. Again, the next one, first I'm going to see if I can divide, which you can, especially with the x's. You can still divide. 189 is also divisible by 7, so this is going to become the square root of 27x to the 29th. Factor tree. So here, looking for my groups of 2, I have a group of 2 right here. And I rewrote my x's because I can easily find groups of 2 in x to the 28th. So I know that I'll have 1 left over. So my final answer here would be I have a group of 3's. So that would give me a 3 on the outside. If I find the group of 2's in 28, that would give me x to the 14th. And I still have my square root 3 times square root x. Again, that square root 3 is from this 3 right here. Square root x is here. Next one, looking at my fraction, can I simplify? Well, golly, I sure can simplify that. This is what it simplifies down to. Now again, there's some numbers you should just know the cubic root of, and you should just know the cubic root of 27. Cubic root of 27 is 3. The cubic root of x cubed is x. Cubic root of y cubed is y. Next one, can I simplify? Yes, I can simplify. So I'm going to first simplify this, and then I'm probably going to have to rationalize. Maybe, maybe not. I'm not sure. So here's me simplifying. Now you should check to see if you can take the 4th root of 81. I know that already. That will be an even number because that's 9 times 9, and 3 times 3 is giving me the 9. So I know that this will give me the cubic root of 81 is 3. And I can easily find the 4th root of x to the 4th. There's one group of 4 in there. And I can easily find the 4th root of y to the 8th because there's 2 y's there. So my final answer would give me a 3 and an x on top for the 4th root of 81 x to the 4th. And the 4th root of y to the 8th is y squared. And the last one on this page, again, can I simplify my fraction first? One thing I noticed right here is do not forget about this 2 right in front, because a lot of people would forget about that while they're simplifying. So first simplify your fraction. Now with math, there's multiple different ways you can go about doing something. One thing, you can simplify your fraction first. So I'm going to simplify both the roots on top and bottom before I start rationalizing it. And the reason why I can do that is because I noticed that I can take the cubic root of y cubed. That becomes just y on the outside, so I have the cubic root of 6 left over. And I for sure know I can't simplify the cubic root of 6 because only 2 times 3 multiply to get 6, and I can't simplify that any further. I can also simplify x to the 5th. So x to the 5th could become x to the 3rd times x squared. So I can simplify this x to the 3rd because I'm looking for cubic roots. So that would be 2x, because that would be the cubic root of x cubed, and I would still have the cubic root of 5x squared. So now I have to rationalize this. So if you focus your attention over here, I just rewrote that same thing. So rationalizing this, I don't want the cubic root on the bottom. So when I'm looking at this, I only have 1 5 here. In order to take the cubic root of this, I need 2 more 5s, 2 more groups of 5. So that would be the same thing as 5 squared. So I'm going to have the cubic root of 5 squared. I have 2 x's underneath that root. I need 1 more x to make a group of 3. And remember, whatever you do on bottom, you have to do the exact same thing on top. So I'm going to multiply those across, getting this. Now I want to see, can I simplify this any further? So again, when I'm looking at this top, 5 squared, there's 2 here, and then I have a 3 and a 2. So I can't simplify this number any further. I'm going to have to multiply that. Now that I have the 5 cubed from multiplying these two together, that gave me 5 cubed, and the x cubed from multiplying these together, this is where we can simplify. So my final answer would still have a y on the outside, the cubic root. This would become 25 times 6, which would give me 150. I still have that x underneath that cubic root. These come out. So this would become 2x times 5 times x. So that simplifies to be 10x squared. Remember, when you have this, you cannot simplify that. Do not do that. Don't simplify these either, because these are inside the root. These are not. They're completely different. Oh, where does that come from? They're completely different numbers. Oh, that looks weird. However, I'm just going to write my answer right over here. So it's the cubic y, and then the cubic root of 150x over 10x squared. Question 21. When I'm looking at my roots, you want to make sure that the indexes are the same, and they are, and the roots are the exact same, and they are. So then you're just taking your numbers in front. 10 minus 5 would give me 5 cubic root of 10a. The root does not change. I cannot simplify 10 because of only two numbers. Multiply to get 10 are 2 and 5. It doesn't simplify. 22. So the first thing when I'm looking at this problem, I'm going to have to simplify these. So I'm going to do my factor tree for each one of them. In my first one, I have a group of 7 right here, so this simplifies to be 7, and then the square root of 5, because that 5 is left inside. Plus, here's a group of 2, so I'm going to take out a 2, and then I'm going to have the square root of 5, and then minus 5. Remember, right here, the square root of 5, that's like there's an invisible 1 right there. So now, since they all have the exact same root, now I can combine them all together. So I have 7 plus 2 would give me 9. 9 subtract 1 would give me 8. So my final answer would be 8 square root 5. That square root 5 does not change. So again, looking at 23, I'm going to have to simplify those radicals first. So my first one, I have a group of 3 right here, leaving me with a group of 3. This 3 has to get multiplied by that 10. Whatever on the outside has to get multiplied by what's coming out. So this becomes a 30 square root of 3. Here's a group of 2. This 2 has to get multiplied by that 4. This is still a subtract, so 4 times 2 would give me 8. And I still have this 3 right here, so I still have the cubic root of 3. So now I'm taking 30, subtract 8, so that would give me 22, and then my root is square root 3. Last one, again, still looking to have my factor tree for both of these. However, now I'm looking for groups of 3. Always be careful with your index. So here's a group of 3 and a leftover. So this becomes x. So I should actually say 3. And then I have this x. Where does the x come from? Cubic root of x cubed is x. So I have 3x. And then here I have a group of 3, or a group of 2. I have 3 groups of 2 right here. So the 2 comes out. So it's a subtract. I can take out that 2. Same thing here, cubic root of x cubed would give me just x. Now I can take the cubic root of 2 for this 2 left over. I forgot to write the cubic root of 2 right here. Now since these are the exact same, x cubic root of 2, x cubic root of 2, I can combine these two together. So now I'm just taking this 3, subtract this 2, so I'm going to have 1. So my final answer here would be 1. I don't need to have that 1 there, but I can if I want to. Cubic root of 2. This is the index, not x to the third. That is an index. I'll make sure to write it right there. Number 25. Sin alive with number 25. For this first one of multiplying, I'll go over in detail how to do it. However, the other ones I will be expecting you to know how to first, outside, inside, last. So here's my first two terms. That gives me the negative 14. Outside, negative 2 times, there's no number here, so it would be 1. So it would be a positive 2 times 1 would give me positive 2, and then the square root of 6. Inside, this is like a negative 1 times negative 7, which gave me a positive 7, and then the square root 6 times, there's no other square root, so it would just be square root 6. And my last, negative 1 times positive 1 would give me a negative 1. Square root 6 times square root 6 would give me square root 36. So again, that's how you get your first 4 terms. That's something that if you're not sure how to do, you have to come in for more help. One thing is typically, but not always, this last one will usually simplify. So the square root of 36 is just 1, so this becomes negative 1 times 6, which becomes negative 6 right here. This whole thing turns into negative 6. These two can be combined together because they both have the same square roots. So 2 plus 7 would give me 9 square roots of 6. And then, because this becomes just a whole number, it can combine with the negative 14 from the beginning. So negative 14 minus 6 would give me a negative 20. So this was a positive 9 square root 6 and a negative 20. Negative 20 plus 9 square root 6. Next one. So I'm going to give you the first, outside, inside, last. So that's my first, outside, inside, last. One thing maybe you noticed from the get-go, these are the same two numbers, but different signs in the middle, so they're conjugates. And conjugates will always make your two middle terms completely cancel. So what I really have here is 5 subtract 11, because the square root of 25 is 5, and the square root of 121 is 11. So I have 5 minus 11, and 5 subtract 11 would give me a -6. Next. So again, you have to multiply first, outside, inside, last. This one is slightly more tricky, only because I can't simplify this because it's prime. Only 2 and 2 and 3 multiply, get 6, so there's no pairs here. There is a pair of an 18, so I can simplify 18, because 9 times 2, so this will give me 3 and 3, so there's a pair of 3s that I can take out here. So when I'm rewriting this 3 would come out, and the 2 stays inside. So I have my 100 minus 10 square root 3 plus 10 square root 6 minus 3 square root 2. And when I'm looking at these, none of these are the exact same root. None of these can be simplified together. Again, because I have those fat fingers, I'm not even going to try to write that on that line. So 100 minus 10 square root 3 plus 10 square root 6 minus 3 square root 2. Next one. First, outside, inside, last. Square root of 4 is the same thing as plus 2, because the square root of 4 is 2, so I'm not going to cancel that out. These two are like terms, giving me 14. 12 plus 2 is 14. These two are like terms because they both have that square root of 2. So plus 7 square root 2. That's my answer for question number 28. Again, I'm just going, you should not do that. I can do that. I'm the teacher. You should write it on the line. Next one, I have to rationalize my denominator. So question 29, I see adding and subtracting. That means I have to multiply by the conjugate. Again, what is that conjugate? Oh, I'll tell you. The conjugate, when you're looking at the denominator, is the same two numbers. So in this case, it's 3 and square root 5. Whatever is in the middle, you want the opposite. So if this is adding, this should say subtracting. So I want to put subtraction. Now, whatever you do on bottom, you have to make sure to do on top. Now, a lot of times people for these problems, they forget that they have to FOIL the top and bottom. I personally am going to write my long division bar because you have to do the first, outside, inside, last, and top and bottom. So right now you should pause this and try to do it yourself. Oh man, that was a lot. So here what we have, first, outside, inside, last, top, and bottom. One thing you can, some people are able to do mental math and know that the square root of 30 can't be simplified. But if not, you should check it. So I have 2 times 15. I have 3 times 5. There's no pairs there, so I can't simplify the square root of 30. However, one thing I do notice, again, if this does not happen where these two numbers can't cancel each other out, you did something wrong. These two should always cancel. You should not be left with a root. The square root of 25 is 5, so I'm going to cross that out because I'm going to rewrite -5. So I have 9 minus 5 here. So my final answer would look, so I can't simplify anything on top, but I do have my 21 minus 7 square root 5, all these fat fingers, minus 3 square root 6 plus the square root of 30, that's a 30, over 9 minus 5 is 4. You can't simplify this any further. That's your final answer. Next one, when I'm trying to rationalize my denominator, I only am looking for pairs of 2, because remember if there's no number, it's a 2 right there. I only have 1 5, that means I need an extra 5, so I need a square root 5 on bottom, and I need a square root 5 on top. So on top, make sure that you distribute to both of them, and you get 2 square root 5 plus square root of 25 over square root of 25. So now when I'm writing my final answer, the 5, the whole number should come out in front. So it would be the 5 plus 2 square root 5 over 5. When I'm looking at this can't be simplified because look at all 3, not just the 2 5s. You cannot cancel out the 2 5s. All 3 have nothing in common. So this would be my final answer. This next one, again, you get to rationalize the denominator. One thing I know though, 18 and 8 are not simplest radical form. I personally like to simplify beforehand. So I'm going to do the factor tree for 18 and 8. So square root of 18 simplifies to be 3 square root 2 because there's a pair of 3's and then 2's left over. And 8 simplifies to be 2 square root 2. So now I have to rationalize this. So I'm looking at the bottom of my fraction. I have a 1 and a 2 square root 2. Those stay the exact same. My middle arithmetic would be adding, so I have to make the other one subtracting. Remember, this has to be the exact same on top and bottom. You have to FOIL the top, you have to FOIL the bottom. These are long problems. So I got my long division bar, and then I'm going to do my first, outside, inside, last. So those are what your term should be for first, outside, inside, last. When I do this, I see that I have a square root 4 on top and bottom. So on top, this would become negative 6 times 2. So I'm going to cross it out. And then actually, 6 times 2 is 12, so this becomes negative 12. So this can combine with this on top, and also my 2 square root 2's can combine on top. So I have on top 3 subtract 12, which would give me a negative 9. And negative 6 plus 3 gives me a negative 3. Again, negative 6 plus 3 gives me a negative 3, square root 2. On bottom, these two cancel out. And if they didn't, you did something wrong. This becomes a negative 4. Square root of 2, or a 4 is 2, so this becomes a negative 8. So now on bottom, what I have is 1 subtract 8, which would give me a negative 7. So that right there is going to be my final answer. Again, fat finger problem, I'm not going to write it on the line. Next. Oh, these are pretty big. So now I'm going to use my properties exponents. Or you could, if you want, I'm going to show you 2 ways to do this. For all of these problems, you can do them both ways. You can look at your properties of exponents, but your properties of exponents can only use if your bases, so in this case, my 2 bases are 4, so I can use my properties of exponents. So I could do 4, and then my property is add the 2 exponents to the first. Or you could rewrite this as this is the square root, because my denominator here is 2, so that would be the square root. And then you can multiply your 2 bases, the square root of 16, which is also 4. So for question number 32, your answer is 4. So for question number 33, I cannot add 1/3 plus 1/3. Why? Because my bases are different. So since these two are different, you cannot you cannot add your bases. However, I can do the cubic root, because both of these are to the 1/3 power, so I can do the cubic root, do 16 times 4, which would give me 64, and the cubic root of 64 is just 4. If you didn't know that, you could do your factor tree to figure that out. 34. Oh, I noticed that they have the same base. However, in this one, I cannot rewrite this with a root, because these roots are different. This is a half root, this is a third of a root. So I actually have to first do my power to a power. Since I have the same base, I can add my 2 exponents. So 3/2 plus 1/3 is the same thing as 5 to the 11/6. Now again, there's 2 ways that you can go about doing this. You could rewrite this as 5 to the 6/6 times 5 to the 5/6. And then this cancels out to just be 1. So then I have 5 to the 6th root of 5 to the 5th. Or if you rewrote this right away, this is the 6th root of 5 to the 11th, which again, you can simplify, which would be 5 to the 6th, 5 to the 5th, still the same thing of 5, and then the 6th root of 5 to the 5th. So this answer actually would look like 5, and then the 6th root of 3,125. Again, that's 5 to the 5th. Next one is just rewriting the simplest radical form. So you're looking at your denominator. That's the same thing as your index. In this case, this will be the 5th root of x cubed, because your denominator here is, see, 5 fingers, scan, circle 5. 5th root. Here, this is the square root. So in this case, it would be the square root of x to the 5th. And you can rewrite that because you have 2 groups there. You could rewrite this as x to the 4th times x. So it would be x squared times the square root of x. Oh my gosh, we're almost to the end. My only friend, the end. So I can multiply these together. Again, I cannot rewrite this as a root yet because these two have different denominators. So I cannot rewrite it as a root. I have to multiply them. So 11 times 2 would give me 22. And then I'm going to add these two fractions together, and I would get x. I already wrote the x. I don't know why I wrote it twice. To the 14/15. So I would have to rewrite that as a root. Now 22, when you notice here, 22 does not have this 15 with it. The 22 would be on the outside of the root, and that would be the 15th root of x to the 14th. And you cannot simplify that any further. So that right there, bing bada boom, would be your final answer. Next one. There's two ways again that you could do this. You can rewrite this as a cube or do power to a power. I'm going to show you both ways because you can choose whichever way you want. Now, if you're going to be doing properties of exponents here, I'm going to rewrite the 27 as 3 cubed a to the negative 9 raised to the 2/3. And now I have my power to a power, and you multiply 3 times 2/3, which would be the same thing as 3 squared. And negative 9 times 2/3, the same thing as 8 to the negative 3. Now you should not have negative exponents, and by negative 3 I actually meant negative 6. You can't have negative exponents, so 3 squared becomes 9, that's on top. The only negative exponents with the a, so this would be 8 to the 6. Now if you want to rewrite this as a root, you sure can do that. So, or I could rewrite this as the cubic root, and I'm going to make this into a fraction right away. 27 over 9, or a to the 9th. Now that whole thing was being squared. Where did the square come from? Again, this squared came from this 2 on top. So this is still squared, and this will give me the cubic root. So again, there's two ways that you could do this. I could rewrite it like this, or I could rewrite it, whoopsie daisy, like, oh my goodness, the cubic root of 27 over a to the 9th. That whole thing squared. Those two are written the exact same way. So you could either square the 27 and then take the cubic root, or you could take the cubic root and then square it. Either way, you should get 9 over a to the 6. So that's two different ways that you could do that problem. Next one, 39. So this is the square root of xy squared. Again, I'm going to show you two ways that you could do this. Well, the first thing I can do, because a root and an exponent, I can interchange them. So I could rewrite this as the square root of 9xy squared to the 4th power. Or, if you want to rewrite this as 3 squared xy squared to the 4th power raised to the 1/2 power. Both of these are the exact same thing. So we're going to solve both of them. If I do it with the root, I could do 9 to the 4th power, which would give me the square root of 6,561. Then my power to a power here would give me x to the 4th, and my power to power here would give me x to the 8th. And then taking the square root of that, so if you take the square root of 6,561, you get 81, and then the square root of x to the 4th is x squared, and x to the 4th. Here I could do my power to a power right here, so 1/2 times 4, so this inside stuff doesn't change at all, it would give me 2, and then I can do that, so then I would have 3 to the 4th, because 2 times 2, x squared, y to the 4th, and 3 to the 4th is 81. Got x squared to the 4th. Both of them, same answers. What do you think about that? Here, right away, I see a fraction exponent. I'm going to just do my power to a power first, just like that. And I would have x to the negative 3rd, y to the negative 6. You cannot have negative exponents. They would go on the bottom of a fraction. Now, when you have a bottom of a fraction and when you don't have anything on top, what you have to do is make sure that there's a 1 on top. So this is now the bottom of the fraction. That right there is your final answer. The last one, again, there's two ways. Actually, there's a couple of different ways you could do this. And the only reason there's different ways is because of the order that you solve these. So, first way, and I'm actually just going to go this way. If you find a different way that you want to do it, it could be still right, go for it. So I'm going to rewrite this as x to the 4th times x. And the reason why is because with a negative exponent, that should be moved up top. So negative 1/5 power. So now I can combine these two together. I have x to the 5th right here, to the negative 1/5 power. Now I have my power to a power, so now I can multiply those together. That becomes x to the negative 1. You should not have a negative exponent, so that would be 1 over x. That's it. That's my answer. That's it. Oh my gosh, we did it. 41 problems. Bing, bada, boom, we're done. Hey, put your hand up in the air. Hey, now put your other hand up in the air. Put them together. Give yourself a high five. You did it. Way to ace this test. Proud of you. Can't wait to grade this test. Have a great, grand, wonderful day.